All right, for number 3. All right, for number 3, what do you do with these two exponents? Subtract, okay? So you just laid out the subtraction, okay? And you're doing this very faithfully. You're not complicating things. You have two exponents and you subtract those two exponents. And you will soon realize that they are, well, it's a subtraction that turns into an addition because you are subtracting a negative exponent. So it becomes something like this. And what do we need? We need a common denominator. So so that becomes okay, 3/10 plus 2/10, which is going to be 2 to the 5/10, which becomes half. And again, we have to present this in radical form. So what's 2 to the 1/2 power? Square root of 2. All right. Now, and I would also expect that one proficiency requirement is that when you see something like 2 to the 1/2 power, okay, 1/2 power, your brain has a little direct line and says, oh, 1/2 power is square root. Okay. It would not be a familiar look at the beginning. I promise you. It's okay. It's okay at the beginning. It's kind of slow, but you need to kind of expose yourself to more of this look. Okay. Okay, now for number 4, 5, and 6, doing the same thing, but we are going to have this in exponential form. So again, let's ask the question, what do you do with these two exponents? They will add. Okay. And when you are home, okay, when you are home, you know what I want you to do? I want you to speak out all the thoughts in your while you're doing this. Don't just mumble. Don't just think in your head and believe that you got this. Okay, go ahead, think it out loud, and make sure that you are hearing yourself clearly, so that your brain can actually follow your thoughts. So you have to do 2/10 minus. I'm sorry. Yeah, minus 2/10. What's 2/10? Well, what's negative 2/10 minus 2/10? Negative 4/10. Okay, which becomes negative 2/5. Now, one thing that we usually don't want is that we don't want to leave the negative exponents in the final answer. The reason is people may forget about it. And so what is the meaning of negative exponent? Reciprocal. Okay. 1/, reciprocal. Okay. So if it appears in the numerator, it becomes a denominator. If it's in the denominator with a negative exponent, it will be a numerator. So they just swap places, basically. Okay. We do not like to put negative exponents at the end. So let that be a habit. All right, number 5. What do you do with these two exponents? Nope. Not subtract. Multiply. Power, and then you have another power on the outside. They are multiplying. And again, write it in a way that has a fraction line, not a slash. And can you see something that can be reduced? Which two numbers can be reduced? 2 and 6, right? 2 and 6. So you multiply them. So that becomes y to the negative 1/9 power, which is simply 1/y to the 1/9 power. Keep it as 1/9 power. You don't have to change it to a root. But if we have to change it to the root, what root would it look like? This would be we call it a 9th root, okay? A root with a 9 on the side. Okay, but we keep it like this. All right, number 6, we have this one right here. So we only do things with the same term, with the same base. So what do we do with these two exponents? Subtract. And same thing for y. So therefore x, it's going to be negative 2/5 power minus 9/10 times y to the 1/6 power minus 1/3. Okay, so common denominator. I am okay that you skip this part and go straight to the next step, which is the answer. Like if you say, oh, I did my common denominator in my head, I'm okay if you skipping it. Just make sure that you are not making any careless mistake. Okay, if you make it, I would say maybe you don't want to skip step at this point. So you have x to the negative 13/10 power and y to the negative 1/6 power. Yes? Negative 4 minus 9. It's 13. Okay. So therefore, and since they are both negative exponents, well, guess what? Reciprocal for both. So it becomes 1 over x to the 13/10 times y to the 1/6 power. Just like this. Okay.